Welcome to the NewSpace India podcast, a bi-weekly talk show that exclusively captures insightful conversations with people contributing to advancement of space activities in India. The NewSpace India podcast is pleased to announce our association with Dassault Systems, a global leader in providing business and people with collaborative virtual environments to imagine sustainable innovations. Dassault Systems solutions support startups, small and medium-sized enterprises, and original equipment manufacturers in developing disruptive solutions for space launches and satellite propulsion. Recently, a supply chain digitization study with Dassault Systems was conducted to provide a foundational understanding of the supplier landscape in the Indian space ecosystem. Please use the link in the description to download the public white paper of the results of this study, which will also give you a perspective on how ready Indian suppliers are to enter the global space market. Hello, everyone, and welcome to this episode of the NewSpace India podcast. And in this episode, we have Pierre Lionnet, who is the Director of Research at Eurospace. Eurospace is an association of European space industry and has been around since 1962. And works with several European space companies and is representing 90% of the total space industry here in Europe. And thank you very much, Pierre, for taking the time for recording this episode with me. Pierre is an economist. He has a bachelor in economics and finance from France, and also then a master in industrial management and innovation. And so Pierre is the first economist that I have on the show here, and I wanted to bring him on the show to talk about how a space economist would look at the space industry and what are his perspectives of how the industry would progress and further on. So Pierre, before we begin diving into the topic itself, I would love for you to give a background of yourself a bit more than what I already told the audience.
Well, thank you very much for having me. So yes, a little bit of an introduction. I am, as I said, an economist. When I started my studies, I was interested in banking and finance. So this is what I studied formally. So I'm formally trained in banking and investment. I was very much interested in the venture capital approach, and that was very new at the time. I'm talking about the late 80s. And so I started working for a venture capital firm, which I supported for 2 years. And from there on, I realized that money was not the only dynamics of venture capital, but when you were looking at seed and startups, technology and engineering, innovation were always the core terms. So this is where I made my master's studies after that. And in that context, I was involved in space for the first time because I was offered a study work for the European Space Agency. And so this is what I did in 91 and 92. I made a work study for ESA, assessing the value of human in space. That was a very interesting work. And after that, my career in space was launched because I attended the ISU in 1993. And after that, I joined Eurospace as a research analyst in 1994. And obviously, I felt very well in this organization because, you see, 30 years after I'm here, I am research director. I'm also the managing director of the association at this point. And I have had a lot of opportunities to speak with people in the industry, to discuss technology, innovation, research, but also economics, markets, and market assessments. We do a lot of interfacing with the European Union, with the European Space Agency. And as you can imagine now, space economy has become a very, very hot topic. So I believe that this is an interesting thing to bring up to your audience today. And so I stay ready to discuss with you this.
Absolutely. I mean, I look forward to learning more from you through this conversation. So we do know that unlike many other sectors, when a sector is kind of mature, there is no government presence in that sector. And you can look at many sectors and you don't think of, the car industry, or people don't say the government is running the car industry, or even mature industries like the aviation industry, where initially governments may be involved in maturing that industry or financing players to mature the technology or to subsidize the development of the technology. But then eventually, the governments actually become one part of the chain where they may be customers of it. but they exit, and then there is a B2B ecosystem or a B2C ecosystem that takes over a lot of this, right? So, but in space, we think of always the space industry or something like that, right? So we talk about all of this. So, but in that sense, do you think the space industry can live without governments at any given point of time? Not just from 60 years ago, or even today, governments are heavily relied on by the private industry. But do you think that space can live without governments, or where governments can also be just one of the customers that are out there among 100 other customers there?
It's a good question, because it's part of the trend that people label the commercialization of space. So I think that this trend is very badly understood. I would like to go back to the beginning of your question, where you were actually mentioning the aeronautic industry. I think that the space sector can be, to some extent, compared in its evolution to the aeronautic industry. When aeronautic industry was launched, the first requirement for air flight was the military. So it started there as a military trend and dominance in the air. Then this industry was established with government investment and government customers. And progressively it started branching out with a civil component. And so the first airline companies were created, but if you look at the situation worldwide, most airline companies were public operators. We have had the same in space. We've had the first requirements for space that was really dominance, military, and I would say it was the Cold War and the race in space between the USSR and the USA. So it was really a government drive, a government demand. And then at some point in the 80s, some commercial applications developed, and we have seen the establishment of a few satellite operators as government entities: Eutelsat, Intelsat, Inmarsat, Insat, etc., etc. So clearly there was a government drive. With the airline business, a lot of the transportation business associated to airplanes now is what I call B2B or B2C. So the end user of the airline system is the consumer or the private sector, the companies that pay for the trips, the companies that pay for the transportation. Now, governments only represent a very small fraction of the airplane procurement system, and they are very secondary users of the airline infrastructure. In space, this is not the case. Some people are saying this is not the case yet, but it will be the case in the future. I am more prudent than that. Today, we need to keep in mind that governments are still buying 80% in terms of mass of all the spacecrafts that are launched in space. They are buying 80% of all the launch services that are used to launch those spacecraft. They are paying probably 90% of all the research, technology, and innovation. Space systems are not in the World Trade Organization, so they are not free to trade. When you want to commercialize a satellite, you must have authorizations locally. You must have authorizations for exports. The launcher technology, which is missile technology, is still regulated by the Missile Technology Control Regime. So this is also heavily regulated by governments. So you like it or you don't like it, governments keep control of space at all times, still today. Space commercialization can only be done if the governments allow. So this is very important. Today, governments, as I said, are the main customers. Then there is politics. In some countries, the governments, they acquire the space infrastructure, and then it is produced, developed, designed by the private sector. This is the case in the USA, in Europe, and Japan. So we have a mix and match between public and private. We can say we have commercialized space. This is what the Americans say. Since it's the private sectors that are actually designing and producing the systems, they say it's a commercial industry. But the core demand is from NASA and the DoD. It is a public customer demand with a private industry. But in other systems, the government orders the infrastructure, and it is a publicly owned industry that produces it. This is the case in Russia, in China, and very much in India, where ISRO today is the major demand, but is also configuring most of the production and the integration aspects of the systems. So you see, we have different policies. But if you look at this case where we have 6 big powers, USA, China, Russia, Europe, Japan, and India, and within those, 3 have majoritarily government-controlled space production infrastructure, and the other 3 have a majority of government demand, but they have a private industry that produces the system. Overall, if you look at the 6 main space powers worldwide, most of their dynamic is under strict government control. Most of the demand is from governments, and in the end, the core economic factor of space development are governments. And then to conclude, you have to look at the applications. Most space-related applications, they serve public policies. I don't see a B2B market for weapon guiding like what the GPS is doing. I don't see today a B2B or a B2C market for global meteorology. I don't see a B2B or B2C market for space science. So for me, space is mostly what I would say B2G, business to government. And it will stay so for quite a while. A few secondary B2B and B2C business cases are emerging, such as broadband internet by satellite, such as mobile telephony by satellite. Yes, they exist, but I believe that from an economic point of view, there are secondary markets. There are markets that exist because the primary B2G demand has allowed the infrastructure to emerge and the technology to be there. And then last question that you were asking, will those B2B, B2C business cases become more important than the B2G business case? This is very much a speculative question. I'm a prudent person. Some people say I'm pessimistic. But today, I believe that with the business of Starlink, the business of OneWeb, the business of Kuiper, there may be the potential with this broadband internet directly by satellite that this business becomes in volume more important than the business and the demand from the governments. In that context, it could be a disruption of the whole space economy. But today, this disruption is not yet there. It is showing the premises. We need to see if Starlink becomes technically and economically viable. We need to see if there will be enough room for OneWeb, for Lightspeed, for Kuiper. And then maybe we will see that these people will create a demand for space systems that will be bigger than the demand from governments. Then we will say, yes, the commercialization of space has happened. Those are the only applications where I believe there would be sufficient volume demand that it can actually become a key driver for space. All the other emerging B2B and B2C applications, I'm talking about Internet of Things, I'm talking about observation systems, I'm talking about scintillography, and all those, I believe that those, even if they develop a lot, will remain secondary in the total picture.
Right. Thank you very much for that, very nice introduction as such, which puts a lot of context as to how markets function at this point of time and how different countries have different approaches to all of this. When it comes to, how space industry is really looked at from a standpoint of the size of the industry or even the view of what is going on, there's a very transactional nature of viewpoints, right? So people say there is, this B2B or B2C market opening up with LEO internet, or they'll say this geospatial data play is happening where people will be using, all sorts of companies will be using geospatial data. And there is a lot of these, let's say, hyped up consulting kind of viewpoints on all of this, saying the market will be 10 times in 10 years or 20 times in 20 years or whatever it is. And some of these go to ridiculous numbers of saying it will be 2 trillion by 2040 because of asteroid mining and all of these things that come up with analysts and and so on. So when you look at it from an analyst perspective, they may be projecting a future where a lot of things align and their predictions are right on all of these things. But you are coming from a economist kind of a background. So what is the difference between how a space industry analyst who predicts, whoever that bank has that said the market will be 2.4 trillion by 2040 is, and what is the pragmatism that a space economist brings when it comes to assessing the industry?
So it's it's a difficult question because then it will appear I'm criticizing the work of other people. So I think that people need to understand one key point. A consultancy is a business which has a number of methodologies and usually a lot of very valuable human resources. Actually, I'm very much friends with a lot of people that work in consultancies, and some of them have been working with me at Eurospace previously. So what people need to understand is that the consultancy is usually producing work as an answer to a specific question that was put by a customer. Consultancies will not produce work just because they have intellectual curiosity. This is the difference between the economist, which is there sitting and thinking, and the consultancy, which is there considering a requirement from a customer, or is producing a multi-customer view because it needs to sell it. What we know is that it's always easier to sell a prediction which looks at a good future than selling a prediction that looks at a bad future. So when you look at prospects and forecasts, usually in space in the past 30 years, I've always seen skyrocketing forecasts. I have never seen any consultancy looking at the situation today and say it will be bad tomorrow. Buy my report that tells you it will be bad. That doesn't work. Also, we see a lot of studies which have been produced, and thinking about the Price-Waterhouse studies for the European Union. They have a mandate to show what is the downstream value for Earth observation systems as a way to justify the expenses in Copernicus. But then the question includes the answer. You have to show the value. The consultants cannot come and say, I cannot measure that value. I'm sorry, I don't have the tools. So they have to design the tools. And sometimes this is where the methodology becomes dodgy, inconsistent, incomplete. So they need to find things with a euro mark. So one of the best known studies we have today from a consultant's point of view about space economics is the one produced by Bryce, which is the State of the Space Industry report, which is something I understand they do with the funding from the Satellite Industry Association. And for that one, they develop an assessment in which they include a lot of things in what they call the space value-added chain. And notably, they include the value of TV broadcasted by satellite into the satellite value chain. So they say that much money was spent by people that have a subscription for pay TV, and they receive their TV signal by satellite. So we count that in the satellite value chain. This, I believe, is methodologically incorrect. I mean, it is like, that was an example I got on Twitter. It is like saying the value of the airline travel includes the salaries of the people that travel in the airplane. You see, the value of the subscription for satellite TV is what people pay to get the contents. People don't care if it is delivered by satellite or by ground ADSL. This is not the value of the satellite service. The value of the satellite service is easy to assess. It is the value paid by the TV company to broadcast. This is the value we know. So consultants, they find data, it seems relevant, and then it is included without critical thinking. To develop a little bit on that, and then we will wrap up, but this question of the TV signal transported by satellite, the people in Bryce, they include the pay TV. So the ones for which there is a subscription value, because it is easy to trace. But we should recall that only one channel out of 3, which is broadcast by satellite, is a pay TV. All the others are free to air. Why isn't that value included in the same value chain? Because intrinsically, if they say pay TV is the space value chain, why free TV is not? Free TV is paid for by advertising. So they should go and look for all the other TV channels, look at their advertising revenues, and pile them up on top of the figure. So those studies usually are incomplete methodologies and sometimes slightly inconsistent. So what the economists think is this is an issue. What is the actual value of satellite services? Who is paying for that value? How much of that is free? What is the usefulness? How can we assess the value of a free signal? What is the value of the GPS signal? The GPS signal is free to air. The Galileo signal is free to air. How do we assess that value? This is a challenge for the economists. For the consultancy, the answer is easy. It's free, the value is zero. It doesn't have a euro or a dollar tagline. So that's the limitations. So consultancies usually apply solid methodologies to a question, and in the end, the report they produce is an answer to that question. And I invite the people to ask themselves, why was the question asked in that form? And this is what explains why the consultancies come to that kind of assessment. Again, it's not a one against the other. It's a different purpose. If you sit down as an analyst and you ask yourself, what are the dynamics of that market? What is happening? You are not concerned with answering a specific contractual request, but just understanding a situation as much as you can, and then using the economics toolbox to answer those questions and provide support to your analysis.
Right. Thank you again, for that insightful thought around all of this dynamics that are happening as such. So we see a lot of these studies quoted all the time, all over the place by almost all different governments and even policymakers all the time. And one of the figures that always keeps popping up is the space industry is $350 billion big. It is $400 billion big, or whatever it is, and it's been growing 3 or 4 or 5% every year for the last 20 years. And they extrapolate all of these numbers to say that the ground systems is 1/3 of the industry, and the SATCOM industry makes 2/3 of the industry, and then remote sensing is $10 billion big, or whatever number is in that sense, right? So, and people are unfortunately the methodology behind and the data behind all of this is not available to us. We are presented the end graphs of how big this is and so on to assess what is the methodology and what is the data that has been used. Even if the sources of the data is not mentioned, even just to know the methodology itself is not really public. So we don't know how much we can trust this information of how big this industry is, right? So how should we be measuring the size of the space industry, from your perspective?
Well, first, it's very difficult because, as I said at the very, very beginning, the space industry starts as a space infrastructure. The space infrastructure is composed of the satellites, the launchers that are used to put them in orbit, and the ground systems that are used to operate them. So this is the higher end of the space industry. Then this infrastructure is procured and operated by a different set of users. You have the space agency, you have the armed forces, and then you have a few commercial or near-commercial operators. Okay? So this is the top level. I have made the intellectual speculative exercise of putting figures on top of that. It's difficult to do because most of that infrastructure is produced in a non-market economic approach. I insist a lot about that. This is the case of what is happening with Russia and China. So let's recall one key point. 80% of the activity, the volume of satellites launched in space, is launched by governments. And when you look at the USA, Russia, and China, those three alone represent 70% of those 80%. So basically what I'm telling you is that 60% of the total volume of activity is driven by three main customers: the US government, the Russian government, and the Chinese government. When you look at the value of expenditure of those three governments, you are left with a difficult situation because in the USA, everything is plain and transparent for NASA. Actually, NASA is the most transparent public institution in the space domain. So you know everything about NASA. The contract value, how much they spent, how much they consume, who are their contractors, how much they give to each contractor. I mean, it's a crazy transparency. We would love to have the same in Europe for ESA. We would love to have the same in China, but we don't. NASA spends 23 billion, and we know how every dollar is spent. Then we have the DoD, and the US Congress produces a number of assessments and tells us that the DoD may be spending maybe 23, 24 billion dollars in space as well. So we have USA maybe 44 billion. And then we have China. In the same year, 2019, China government launched as much as the US government in mass. So the same mass of satellites was launched by USA government, by Chinese government. And almost the same amount was launched on behalf of Russian governments. For China and Russia, we have no figure. So what can we say? So we say it's the same volume. So if I was counting cars, I would put the Hummer on one side, then maybe a Chinese equivalent of a 4x4 car, and then the Russian equivalent. How can I put a value of the Chinese and Russian car if I don't have a market figure? I can't. Then I have to look at the service provider. Is this car transporting the same number of people? Is this car, does it have the same horsepower? If we have this kind of analogy, then we can say the value of the car is the same. And so if that car costs $1,000, then maybe I can say the Chinese value is $1,000. So we do analogy. With that type of analogy, I would like to say that today, spending for space infrastructure worldwide is in the order of $120 billion. So this is the volume of money which, by analogy, is available to fund the production and launch of satellites worldwide, 120 billion. And for those 120 billion, 110 would be money from the governments, American, Chinese, Russian, European, Indian, Japanese, UAE, etc., etc. So 110 out of 120 would be government money. The 10 billion left would be from the private sector demand. So this is the situation today. The space market at the infrastructure level, it's 120 billion value. Is it growing? Absolutely no. In the past 10 years, it has remained almost stable. There has been a little bit of growth in Europe, a little bit of growth in China, but absolutely not the 7% that Bryce is measuring with its State of the Space Industry report and Global Space Economy. It's not 7%. This has been confirmed very recently by a good study made by the Bureau of Economic Analysis, which is a government agency in the USA, from the Department of Commerce. From their perspective, the space infrastructure business has grown between 1 and 2% every year in the past 7 years, which is a level of growth which is lower, smaller than the global growth of the US economy. So this assessment made on the space economy with this 7% growth, it is incredibly wrong from my economist perspective, because it accumulates value that has nothing to do in that total. That was my example before with the value of pay TV. Also, I would like to make another comment. This, my 120 billion assessment, is the top layer. Below that, there is what we economists call induced market. So you have an infrastructure. People need to produce and buy other stuff to use the infrastructure. This induced market has three major components. There are the terminals. There is the value of the services sold. And then there is the added value made on those services. This is what we may call the downstream component of space. The terminal business today is the biggest one we know. The terminal market, which includes the satellite dish to get your TV signal on, which includes the VSAT networks, which includes the antennas that you install on planes and ships so that they can have internet on board, which includes the chipset you have in your smartphone for the GNSS signal. All this market, it is more or less 80 billion in value. So this terminal market is 80 billion. This is directly induced. This market would not exist without the space infrastructure. So in total, I would say the space economy is 200 billion, 120 for the infrastructure, and 80 billion for the terminals. And then there is the induced services. If you use Waze, if you are using Google Maps, at some point, your location will be indicated thanks to the GNSS signal. This business of creating those apps, of selling those apps, has a value. Those apps would not exist without the GNSS signal. So the GNSS signal is included in those apps. It participates to that value added. But how much? We don't know. What is the value of those apps? We don't know. So this is where we have the gray area. There is the Earth observation data ecosystem. It is the same. Earth observation data is almost always free. All the Copernicus dataset is free. The Landsat Radarset historic dataset is free. The Meteo information dataset is free. So we have companies that use this data, repackage it, and sell it as a service to other companies. This market is not well known. People say it's 4 billion, 6 billion, 2 billion. I have no idea. We don't really know because the boundaries are not known. So it's difficult to assess, but if we want to put a figure, I would say, let's say that this value added from space-induced applications and service, it's maybe 80 billion. And most of that is the mapping and guiding applications, localization, etc., using the GNSS. So we say 120 billion from the infrastructure, maybe 80 billion or 100 billion for the terminals, and maybe 80 billion for the services. The total would be 270, 280 billion tops. And it is not really growing. And what is growing is the market for terminals. What may be growing is the market for value-added service. But the infrastructure market is very stable and is not growing much. One comment. The induced market can grow even if the infrastructure doesn't grow. You can have more Galileo, GPS-enabled terminals without the need to grow the Galileo infrastructure, because the signal can be consumed at all times by all users without limitations. It is a typical public good. On the other hand, now we are seeing the Starlink approach. Starlink is different because more users will require to grow the system. The system will have to grow to accommodate more bandwidth if there are more users. So with those market applications that could be disruptive in the future in terms of volume, we would also see a direct causal link between the development of the infrastructure and the bandwidth which is rolled out and the development of the users. And so you will have more terminals with a requirement to have more infrastructure in satellites, and the other way around. You'd roll out more satellites to enable a larger market. And this is where the economic equation is complex, because this market for terminals will be huge. Musk is saying that there will be millions of Starlink users in the future to generate 30 billion of revenues for Starlink. That means that these people will buy millions of terminals. The market of terminals would be huge. At the same time, Starlink will have to roll out tens of thousands of satellites. That will be a billion value infrastructure in space. This has the potential to change a little bit the economic equation if this whole system becomes sustainable from an economic point of view. And there I would like to draw the attention to the people that 20 years ago, three systems were very well known, Iridium, Globalstar, Teledesic. They leveraged $9 billion from the equity and private investor market. And then they launched and deployed infrastructure, but unfortunately, they didn't manage to find their market, and they all folded and went bankrupt quite in a while. Actually, Teledesic went bankrupt before deploying the system. So we must be prudent. Those perspectives are very exciting. And if this market becomes viable, the market for the broadband internet, I believe it will disrupt the space industry. But it will be disrupted by Starlink and a few others. It's not what I would call a global trend. And the role of various players in that market disruption will be very specific and limited.
Right. Thank you again, for this extremely interesting and insightful answer. Because normally, the guests that I have on the podcast are focused purely on India, and we talk about stories with respect to India itself. And I think this gives the listeners a very insightful approach as to what is going on in the global market and how we can relate with respect to what is going on in India with what you said, for example. And you may be definitely following the current developments and the changes that are ongoing in India as well. We have a lot of policy changes coming up. There is a new public sector enterprise that is increasingly getting more and more funding, where we are almost mirroring the Chinese approach of having a space agency and state owned industries that will compete in the global market. At the same time, you have some of the new space players coming up with their own kind of activity of trying to build their own satellites or launch vehicles and so on. And there's some changes in the policy of opening up infrastructure to private industry to use the state owned infrastructure to do tests, or to not have them invest in the capital requirements that are needed to build all of these very thermovac chambers and vibration chambers and things like that costs a lot, and instead they can use all of this. And at the same time, you have some sectors like broadband internet or IoT or things like that that have been traditionally locked up due to security restrictions or other such restrictions that are out there, being slowly liberalized in that sense. But then we have almost no evidence also on what is the nature of activity in India, how big is the sector in terms of absorption of the activity. Or in fact, unlike even in Europe, for example, at least you have some companies like PwC or somebody doing some sort of a research commissioned by the European Commission, to map some of these activity, to give them at least some sense of what is the size of the industry or what is the size of the activity. But then in India, we don't even have that. There's no specific think tank, or even government doesn't commission anybody to do this activity as such. Or there are no such economists who have done such activity on an ongoing basis as well. So what do you suggest, given the status of the nature of activity, and India is a sizable space player, but we don't have all of these established and so on. So from your perspective, what do you think a country like India should do to do better in terms of evidence-based policy making?
So I will be very very straightforward on this. First, I think you mentioned a very interesting term. You were talking about IoT, broadband internet, etc., and you were noting that there was a government lockup because of security concerns. So let's put that a little bit on the side, but I believe this is where something is touching at something which is very critical for the future of local development and industry. Now let's look at the policy perspective. As I said at the very beginning, today governments are spending in space more than private entities, because so far space-related services and applications seem to be main requirements for governments and policy. And we look at the military requirements, projection of forces, telecommunication support for the military in the field, tactical observation, intelligence, and meteorology, which is a core requirement, for military operations before anything else. So if you look at the US government space ecosystem, all those applications are mapped in and funded to some extent. Then, of course, if you deploy space infrastructure, you must have also military launchers. So basically, we are looking at a military policy for space. I think that India is not really concerned by this, like Japan, like Europe. We don't have a consistent military space policy. We are using space as an asset to produce other type of public goods. Years ago, India decided to use communication satellites for education purposes. Education in very broad terms. Education includes, of course, those very niche sectors such as teleteaching, and broadcasting educational programs, but even having national TV available on the whole territory is an education principle. It's culture. Culture and education was a political decision in India, and this is what I believe was one of the main political drivers for the INSAT program. Broadcast needs in order to create cultural homogeneity and heritage and promote education. So that was a clear drive. There is a need. There is a system that enables to satisfy that policy need. And then you create the industrial infrastructure which is required for this with the agency, with the operator, and you acquire the technical means to produce the systems that support this, which includes the GSLV launcher. It's all part of a political decision which can be difficult to achieve in the end. The results can be complex, but the logic of it is fully consistent. Then I would like to take a step backwards now. What have we today? Today we have a number of different policy requirements which include a reflection on space. We say space will help to grow the economy. Well, to be very honest, I don't think so. Well, yes, it will, but is it a game changer in the economy? Is the satellite economy going to change the global GDP of India in a significant way? Will satellite-related business enable to create so much employment, which at the level of the total employment of India will be significantly visible? The answer, regretfully, is no. Worldwide, the people working in the space industry, the people who are actually manufacturing and operating the system, is less than 1 million. I'm talking about 1 million out of a 7 billion population. Because space systems, space infrastructure do not require huge human resources investment to be produced. So, what is the potential economic outturn from investment in space? Well, it is mostly measured into the development of the downstream and in terms of utility of the services. Again, as we said, meteorology, observation, telecommunications, and so on. And there, I believe we need to draw the line between what is a government requirement for a public service. And in that case, the answer is easy. It is the Chinese, the European, the American answer. There is a government requirement for science, for climate monitoring, for carbon dioxide monitoring, whatever. Then the government sets up the appropriate infrastructure, and then, depending on the economic model and the political model of the country, will put out a call for tender or will organize a local production chain under government control. That is a political decision, but it's easy. There is a political demand, you draw the requirements for the system, and the government launches and operates the infrastructure. The government can even decide to operate the infrastructure as a public finance initiative. That was the Skynet example with the Ministry of Defense in the UK years ago. Instead of buying the satellite for military communication services, they decided to fund a service request by which a private operator designed, developed, and operated the satellite. But the demand is from the government. This is the core point. So this is one line of action. Government demand, government-driven policy. The other line of action is there is potentially a B2B, a B2C market with a space application. If a country wants to make that happen, the main incentive is to deregulate. And this is where you made this excellent remark. Open the legal boundaries, make the frequencies available, reduce the limitations to use technologies and to develop technologies. And if you want to know how much of that business is working, well, the easy part is that you give licenses. If you give a license to operate a frequency, if you give a license to operate a service, like the cell license operators, for the GSM and the mobile telephony, etc., then it's very easy to know what is the economic value, because every holder of a license can be surveyed. So from a policy perspective, every license holder, well, every year they need to fill in a questionnaire. How many people do you employ? What are your revenues? What is your market? What is your business? Whatever. Otherwise, you revoke the license. So you have a win-win situation where with the license attribution, you know exactly who is doing the business you want to monitor. And to renew the license regularly, people need to abide to a number of obligations, such as declaring revenues and employment figures in a consistent way. So it's very easy to know the mapping of the situation when you have either a public demand, So you know who is producing the system. And then it's very easy to assess because you go to the contractors and you look at them. And there are not so many. Either you have a license approach, and then again, it's similarly very easy. Every licensed operator needs to give you figures. The problem sometimes is that governments want to make that bottom up instead of looking at it top down for reasons which I fail to understand. And the bottom up approach, the bottom up approach is always complex because you know, the consultancies, they need to go at little market figures here and there, then they put them together, they compile them, some of them are missing, then they fill up the gaps, and then, you know, it's bubbling up, and you come up with some difficult figure to understand, because as you said, we don't know what's behind, we don't know the methodologies. And I am looking at the NewSpace phenomenon, for instance, and I have an Excel list of now more than 1,000 companies. I mean, even for a person like me, I'm doing it on a rolling my way. If you ask me how many NewSpace companies I have in India, I can roll out my list and tell you probably 50 or 60. Is it so difficult to go and make a phone call to all those companies one by one and to ask them questions? That's not very expensive. And then you could map the Indian NewSpace environment just by looking at the press, looking at the magazines, looking at a sat search, you know, and looking at the India offering there. You can regularly monitor the NewSpace environment in India, in China. I'm doing it for Europe mostly, but this is something people can do just looking at the entities one by one, going to the websites, looking at the values, checking on LinkedIn, sending emails. I mean, it's simple investigation. Anybody can do it. It doesn't require, you know, big mindsets. But for some reason, this doesn't seem the way it is done from the government perspective. They like, you know, to get the bird's eye view, whatever. I don't know why. I think it's distressing to see that. And at the end, it doesn't work. I believe that one of the reasons behind that is that policy is made before assessment is made. So when the assessment is required, it is there to justify the political decision afterwards. And this is where, of course, the consultancies have this very difficult job of producing a report that goes in the right direction. That's difficult sometimes. And this is where policy making is done wrong, you know, making the decision and then looking for the justification. I have been confronted that with my professional career in the past. I have been refusing offers to make studies where people told me, well, we would like to justify this. Can you make a study that will justify this? I said, no, I can make a study that will assess the situation. Then maybe it can justify, maybe not. I can't tell because I don't know yet. He says, well, no, I would really like the study to justify this. Then I said, I'm sorry, I can't do it. I can analyze the situation. I cannot justify beforehand. Why do you need the justification if the decision was already taken? Well, you know, my board would like to have an independent assessment. Okay, but if it's independent, I cannot guarantee the results. Well, then we're not going to make the contract. So you see, this is where the difficulties arises. Independent assessment that needs to justify something beforehand. That doesn't work. Either it's analysis and investigation, either it is political justification. And to go back to your initial question, I believe that most of the reports we see laying around free, accessible on the internet are actually political justifications of some question that we don't know about. This is why sometimes they're difficult to use to make, you know, analytics instead of just justification.
Excellent. You know, thank you very much. That's been very insightful. That the way you put everything together, I think it gives a lot of context in that nature, and it's also a game of incentive because, you know, as you said, the reports that are negative to the market will not sell in the future because nobody will buy that anymore, or the contracts that are not favorable to people who are you know, wanting a certain result ahead of the time before telling what they, you know, would like to see as an independent assessment, again, you know, causes all of these biases. And the problem that I see is that there is no framework that I have seen or come across that gives anybody in any part of the world to say that I can use this framework to get some data, get some information to see what is the activity or size and scale of our industry, local industry, be it at a city level or a or a state level or a country level or whatever level, right? So there's no such frameworks that are available that people can also criticize, saying that this methodology or this framework has these drawbacks or these constraints, and these are the boundary conditions that this kind of framework works in this approach. And that can be used as a standard to also to tell policymakers around the world that the same framework can be used in multiple geographies at the same time, to kind of critique what is going on there, and to then make it very clear that this is what is the basis on which we are going to be making some policies and so on, right? So, and this framework may be created by people in advanced countries like yourself, maybe in France or maybe in US or wherever. You have a very, very long history of doing space, and also industry has been involved in space for a long time, where you have the experience of doing it. And maybe countries that are emerging today, countries like Brazil or South Africa or India or wherever, Thailand or whoever it is, who is developing the industry or starting to see space as a sector that they want to approach or develop as an industry, they can use to assess their developments there using such a framework. Is there a possibility of creating such a macroeconomy based framework that people can use?
Well, first I would like to say that the framework exists. I mean, there are many space economy, I mean, not space economy, but economic handbooks that help you create the framework. I mean, industrial economics is a very well-known area of economic research where you have all the intellectual tools and analytical tools to actually assess any given industrial sector. And this is very simple because you need to look at the production inputs and you look at the production outputs. And then you have very simple measuring tools. For instance, for satellites, we can measure the mass of the satellites launched, but we can also look at, for telecommunications satellite perspective, we can look at the total bandwidth, which is available on a satellite, which is a production index. For observation systems, you can look at the total data which is produced at every orbit, every cycle, how much is downloaded, petabytes, terabytes, and so on. So the methodological framework exists. The problem is different. It is space, as I said, is not a very, very big industry worldwide. If you look at the car industry, it is an industry which is producing hundreds of millions of cars every year. Okay? And then it employs, the last time I saw a figure in France, it said that globally, the car industry, including the people involved in the repair, maintenance, spare parts, and the people selling gas, okay, was maybe 2 million people. I don't know how much of that figure is correct, but only France and only the automotive industry would be 2 million people. And I'm putting that in front of what I believe is the correct figure for space industry worldwide, which is 1 million. You see, so from a macroeconomic point of view, space is not very big. From a geopolitical point of view, space is absolutely massive because space has a geopolitical impact. Space is giving you observation tools to assess the quality of the air in the globe. Space is giving you the observation tools to make tactical decisions worldwide. Space is giving you the GNSS signal, which enables you to know where you are on the surface of the Earth at every moment, everywhere. Space is a global system which doesn't cost a lot. Any country could decide to deploy its own GNSS. Every country could spend those 14 to 20 billion euro/dollars to actually develop, buy, and operate its own GNSS system. It is available. It is easy. A country like India could do it on a blink. The problem is, how would you justify this expenditure from a government perspective? And then I would like to branch to another point, which is basically people want to get into the space arena because it makes them look important. 2 examples. The HOPE mission to Mars Everybody mentioned now that there is a new player in space. It's the United Arab Emirates. They are now on the international spotlight because they made a mission to Mars. What I would like to ask is a question for which actually I don't have the answer, is how much of that was actually made by people in the UAE? The batteries, were they imported or made locally? The solar cells, were they imported or made locally? So one point is buying a system. Another point is having the local industry to build it. Anybody can buy a space systems now, provided that your government is helping you, because as I said, space systems are not WTO, it's regulated, import-export are complex, but anybody can do that. And space systems are never that expensive. The Hope mission, $200 million. So for $200 million, you can send your country to Mars and get, big international exposure. It's fantastic. I mean, how many things you can do with that kind of political impact for $200 million? Another example, the recently created Catalonia Space Agency. I mean, Catalonia is a region. Does a region have grounds to have a space agency? Sarcastically, I would say, well, probably no. But it's a way to be in the spotlight. We say, well, we are a space agency. We are a space power. And they even launched a nano satellite, So maybe they spent 2 or 3 million. And now they can say Catalonia is in space. Big international exposure, big political benefits. But economically speaking, the investment is very small. It's manageable. And the outturn, what it makes to the Catalonia economic growth is negligible by definition, because space systems do not create major economic growth per se. They are enablers for a lot of things. They enable a safer air infrastructure. They enable a safer rail infrastructure. They enable a safer planet globally. They enable a lot of science. They make people dreams, because we have astronauts going in orbit, because we see them playing in the space station, because we hear them making great peaceful messages for a global Earth. We have perspective for actually putting foot on the moon again. We have perspectives of going to Mars. This is the dreamy dimension of space, which is also a benefit, but it's intangible. Most of the space benefits either are provided for free as free services, such as the observation data, the meteorology, the GNSS signal. Either they are rooted with military requirements, so it's very difficult to assess their economic value. Either they are political benefits. And how do you put a euro or dollar value on a political benefit? You're getting the Peace Nobel Prize. Okay, they give you $1 million, but the real benefit is that you are the Peace Nobel Prize. So again, space is a mixed bag of all those things, but the driver in space remains politics, with a lot of high-level political benefits. Then there is an economic dimension, because there is a market for infrastructure. And then there is potentially also an economic dimension because of the pervasive nature of space services and how they enable a lot of things to be done better, more efficiently, in a more advanced way. But this is incredibly difficult to assess. And when you start doing it, eventually you do a bad job and you lose credibility because of the price tag you want to put on everything, which sometimes doesn't work. And this is something you need to accept as an analyst. So you see the difficulty of that. So the political benefit is the core point for me.
Yeah, again, very, very insightful. Thank you again for this view. And the problem that I see is that there are all of these many phenomena that are occurring at the same time. You have a lot of these new space companies coming at the same time. You have a lot of rich people investing, saying we will make people multi-planetary, interplanetary, and everything else. And you have one group of companies coming up saying we are going to be doing new technology and new space and everything else and so on. So there are so many different noises among all the things that are happening at the same time in that sense. And there's some signal coming out of all of this noise that may be beneficial overall and sustainable at the end overall. And so it's very hard to say what is signal and what is noise in all of this, right? So, and with that sense, there's, of course, a lot of the noise coming from saying, there is new space and there is new approach and everything else. So sometimes new space looks like, old wine in new bottles being sold, where you try to say at the beginning that you're trying to do something new, but then you go back to the old way, saying that the only way is to be working with governments and having governments as customers. And for us to do new space, maybe we can do it new space in the future where we are more sustainable. And until we get there, we have to use government money to be sustainable. And so many of the new space players who become bigger traditionally go back to saying, or working in a more traditional space way to be more sustainable and to stay alive to that sense. So what is your view of what people call today new space and what people call as old space?
Well, first I would like to say that I like very much this new space environment. From an intellectual perspective, I think it is interesting, it is stimulating. I am a new space fan, although I may be sometimes putting this new space phenomenon in a different light as the usual new space promoter. So I am a fan of the phenomenon. I'm really spending a lot of time, and I think it's very interesting to look at this bubbling environment of people coming up with the proposals. So for me, I would say something provocative, but I'm used to that, so I like doing it. For me, new space is all about the narrative. It is the storytelling. And this is actually what I think is interesting and sometimes funny in the new space. New space is actually always using the same keywords. The new space, from an image perspective, is about groundbreaking, first movers, breakthrough, space for humanity, mankind, exploration, vision. And the new space promoters usually are establishing themselves in this very positive image set. And if you look at the new space companies' websites, even the two-company startup that was launched yesterday to actually develop, I don't know, maybe a high-thrust electric propulsion for exploration systems, whatever. Well, they present themselves as leaders in something. It's a company that was launched yesterday with just two people. They may be very, very smart. I'm not saying these people are not smart. I'm not saying they're not excited. I'm not saying they're stupid. Absolutely not. Usually the people, they have good mindsets, engineering skills, education, and ideas. The problem for me with the narrative is that it overconstructs, it oversells, it is overly optimistic. Everything must be game-changing, big. And then it is also the idea of saying, we are the best. And all the things that were done before us, they're not good. I would like to take one very simple example. The synthetic aperture radar. So if you look at the SAR business today, it is one of the major areas in the new space. You have lots of promoters. You have all of them are presenting themselves as leaders and first movers. But you have Capella Space, ISI, Predecessor, Synspective, Trident Space, Umbra. Now there's Climacel. Okay, so all these guys are saying, we are going to provide for the first time synthetic aperture radar data to the market. We have the Sentinel-1 satellites that are providing synthetic aperture radar to the market since 2014. You see, so that's what I don't like. That's the part of new space I don't like. It's the way they're saying, look at me. I'm like the new guy, maybe the only guy, maybe the best guy. So the narrative is what at the same time interests me and pleases the eye, and which is at the same time is providing a lot of misleading things. So the new space is the narrative. But what I would like to say about the new space is that for me, what is interesting is to see that there are a lot of new players coming in. And then I put them in two different categories. I look at the ones who want to build satellites and launchers. Basically, they're saying, I want to find new ways or different ways or cheaper ways to make satellites and launchers. Very good. Those are very interesting to look at. Then you have the other guys, the guys who say, I want to operate a satellite service because I think there is business to be done with this specific service. what is interesting is to see that these new guys for the operation side and the new guys for the satellite building and launcher building side, actually they join forces so that some people say, I have new ways of building a satellite. Some guys say, I have new ways of operating a satellite service. And the two things come together because one will sell to the other. Of course, you also have integrated companies like Planet that say, I'm building my own satellite. But basically, it's the two concepts coming together at once, but it's the same thing. We build and operate different satellites, and we create a better service. That's the narrative. The point in that is how much of that can be true. Frankly speaking, it's very difficult to know because one of the key features of all those new companies coming up is that the only thing you eventually know about them is what they put on their website. So they are leaders of something, and they have breakthrough technologies that they cannot describe because it's secret, like AST Mobile. I mean, these guys, their website it's like a novel. You look at the things, the statements they make, and as an old guy working in space for the past 30 years, looking at technology, what space technology can do, what space investment can support, I'm looking at the proposition of these guys, and I'm saying, I don't see how this can work. But that's just my opinion. I can be completely wrong. I mean, they can have found, the major technology disruption. So what I'm saying about the narrative is that it cannot be substantiated. And then you have these reports that come out that says, well, NewSpace is big in money. 5 billion, 10 billion, 15 billion, 30 billion invested in new space companies in equity in the past 10 years. That's an interesting figure. 30 billion, 10 years. Wow. People are impressed. But I would like to put other figures in perspective. The difference in capital assets for a company like Boeing between 2 years is 10 billion already. Just Ariane Group in Europe, I was looking at the figures in the annual accounts of Airbus, which is providing information on the variation of assets for a company like Ariane Group. Between 2017 and 2018, they had 1.3 billion growth in capital assets. So people are putting up this big value of equity money, venture capital money, but the normal industry is also growing. We, in Europe, between the last 10 years, our employment has grown by more than 15,000. So this is the growth of the old space industry during the same period. So I think that this is where also we have a problem because this opposition, new space against old space, I mean, there's been a letter that has been sent to Commissioner Breton by a group of new space players in Germany mostly and say, okay, we want our share of that, okay, of the big market, space cake, whatever you want to call it. Yes, you deserve your share, but like anyone, not because you are new space, but like any other company, you have a good offering, you bid, you win, you have your share. And this is where I believe we need to go back to the dynamics. The people who say, I can build the satellite in a different way, better, cheaper, faster, whatever, please go on, do it, and sell it, find customers. And then everybody will be able to determine whether you're good or not. And those customers, they can be private companies, they can be public entities. But the game-changing story of the new space that says the main dynamics will be private B2B, B2C markets, for me, this is where we have a bit of a problem because those markets still need to be revealed. They're not there yet. That was what I was saying before. Starlink, which is now the most advanced new space concept proposal for broadband internet, which is a B2C market, we still have to see whether or not it will make enough money to support the rollout of the rest of the constellation and full-scale operation. So there is a promise. This promise usually can be revealed, can be fulfilled if two conditions are met. One, if the market is there, and two, if the service is cheap enough to support the market, to support the deployment of the infrastructure. So you see, those are big question marks. So people have a lot of ideas. It is bubbling with ideas. What I don't like is that usually they show themselves as the big new thing, while they're just new, not necessarily big not necessarily better. And I would like this to change because everybody's on the same footing. And then I would like to see with interest whether or not there is a viable business case. But then I would like also that people recognize that if the market is a B2C or a B2B business, they shouldn't go looking for government help to support the development of their infrastructure. Governments, I believe, should only put the money where they are buying the service or the infrastructure. So it is normal for me that in Europe, we have development money, which is funded by the union to develop the GovSatcom system. It is normal that we have money which is supporting the development of the launchers that are used to deploy the European flagship infrastructure. This is normal because it is a government requirement to have those systems in orbit. So they need to provide for that. But I think it's less relevant to say we would need to have support money to develop those businesses that are looking for B2B or B2C business models, because then why shouldn't we support your local bakery? I mean, they want to sell bread to you. Why shouldn't they get government support as well? So I think that the government support, if it happens, should be designed in such a way that every new idea can get a funding, not only space because it is space. You see my point? And then we need to look at what are the business cases of the big guys in the new space. Starting SpaceX. SpaceX is a launch operator, and basically its business is with NASA and DoD first. And its secondary business now is the deployment of Starlink, which is its own constellation. Today, SpaceX is the number one player in the new space. Then we have OneWeb. OneWeb is a broadband system. It's B2B, B2C. Broadband doesn't really require government support. We have Blue Origin. Those are the three big. The guys who actually have leveraged most of the billions that everybody's talking about. Okay? Half the money in the past 10 years has been absorbed by those three companies. And then we have a number of smaller players. I would like to mention Planet. Planet is way below. It's not a billion level company like SpaceX or like Blue Origin. It is a 100 million level company today. Planet launched its constellation with the proposition to actually go and develop its own B2B, B2C business for observation. Now it seems to be that Planet is getting most of its money, revenues, from government, from the DoD or the NSA. So they are changing the business cases. They're moving back to tapping into the governments. So I don't see that this proposition is very different than the other ones. I'm not saying this is a criticism. If you are into the government business, you are making the right choice, because that's what I was saying today. Governments are selling and are buying most of the space infrastructure worldwide. So it is normal to go and look at government money. What I don't like is when they say, government money is not what I want, but then this is what they get. I like the narrative to be consistent, fully consistent. If we look at the deployment of satellites and the launch operations in the future, most of that will be driven by governments. So I don't want to see a launch service operator that develops saying, I don't want government business. Yes, you do. Actually, you should target that first, because this is where money is to be made. Governments are buying most of the launch services worldwide. You see, so new space is great. New space is exciting. New space is really funny. Okay, but new space sometimes has a narrative which is discriminating the others, and this is what I like less. I mean, everybody is doing space systems. Some people have new ideas. Some people have old ideas. Some people are repackaging old ideas as new. I think that this is something that people should know better about. More expertise should be there.
Thank you again, Pierre. So final questions before I let you go. It's been 1 hour and 15 minutes since we started chatting, and it's been very, very, very insightful. Thank you again for taking so much of your time. I want to ask you if you have any prophecies, predictions, anything that you think are relevant for, let's say, the next 5 to 10 year period that you think are insightful, because I want to know, because this is a question that I ask almost every guest, saying, where do you see things heading in the 5 to 10 years? So given that, you've put the worldview in a very interesting context. I would love to know what you think would happen in the next 5 to 10 years.
Well, usually I never look at the future because it's so easy then to be wrong. So, but I think there are a few things that need to be looked into. First, broadband internet by satellite. If this system eventually works, and when I say it works, it's not only a technical assessment, it is whether or not this business service, this consumer service with the Starlink approach, basically with $100 a month in fees, $500 for the terminal, if this actually manages to reach out to a sufficient number of customers to actually support technically and financially the deployment of the constellation and its operations with billions of revenues, it will become a game changer. We will know that. 5 years from now, we will know. Starlink will be a big player, and then probably Lightspeed will also have a market, and probably Kuiper as well. Because if this system becomes the norm, then it will change a lot of things. Also with the way people are, connecting in general, and they can, connect everywhere. That is a big changer. So that's something we need to look into, because today nobody can tell. Well, I believe that Elon Musk believes it will work. Okay, that's his take, but it's a belief. It's not yet proven. So that's one very important thing. Broadband internet by satellite has the potential to be a disruption in the space sector because it will create a new need that will double up, basically, the quantity and mass of satellites we will be launching in space. So it's a doubling of the space sector activity in just 5 years. This will be a major growth and a game changer. So that's main trend one. Then the second one that nobody is considering today, because you need to be looking in a certain direction to understand this, is the militarization of space. What people have not understood at this point is that with all those new developments, well, the things you can do now from a military perspective from space, and when I say military, I'm talking the large community that involves intelligence, the military, and population control. Okay? Those three things are actually the new game changer in space. And when I see, for instance, now that when you look at every Chinese launch, it's almost impossible to know what exactly they're putting in orbit. Well, I am worried. So everybody's talking about new space. Some people, with a kind of conspiracy approach would like to say this is a way to divert the attention of people to what is really happening in space, which is military, intelligence, and population control. So I would like also analysts to take a deeper look at that dimension. And then I would like to conclude on one last thing: science. Space systems, space age was born with science in mind. Now, in my analysis, science is only 5% of the total things which are done in space. I love science in space. Science is climate observation. Science is looking at our Earth. Science is where the satellites are giving us information on what our system is about. The Earth in its totality, but also the Earth in our galaxy. What is our galaxy? What is the universe? This is what space is about also. And then I would like to say something very provocative. Science is not putting people on the moon. Science is not putting people on Mars. Science is knowledge. Knowledge requires sensors, missions, probes, not necessarily people. I don't see a very big value added for science of putting people in space, putting people on the planets. But then maybe there is this other dimension, which sometimes I'm not very comfortable with, which is the dream. So maybe putting people on Mars is part of a dream, but I would say something very strongly. My dream is not living on Mars, because my dream is living a comfortable life. I never see the situation where there will be a comfortable life on Mars. I want to be given the possibility for me, my children, and my grandchildren to live a comfortable life on Earth. That means climate control. that means security, that means freedom and liberty, that means the means to act as a citizen, a citizen of Earth. I believe that space is a major dimension into all those elements. So I like and look upon space for that. So you see, 3 important messages. Broadband internet as a game changer in the next 5 years. Let's see if it happens. Militarization of space. This is happening. I would like more analysis on that. And then space as an enabler for, democracy, citizenship, and the long-term operations on Earth. That's what I'm looking forward.
So Pierre, again, thank you very much for taking so much time. It's been extremely insightful, the conversation. I'll link your profile from Eurospace to listeners to have a look and perhaps even contact you if they're interested to discuss more with you directly. Thank you again for coming on the show, and have a nice day.
Thank you very much for inviting me.
Okay.